My name is Francisco Capucho, and I'm working as a researcher at Instituto Superior Técnico. My academic background is in material science and engineering. I am a passionate volunteer, being working for Erasmus Student Network for the past 4 years. My newly found love is 3D printer, and since I own my 3D printer, I've been printing awesome stuff all the time. Welcome. After an overall introduction to the methods for sustainability and environmental management at the process, product, organizational and system levels, I'll talk on the quantitative methods to measure and track down the inputs and outputs of industrial processes. These are the building blocks and foundation of the following levels. But firstly, we need to define process. A process is a sequential set of activities or steps that interact to develop a product or service for customers. In a life cycle perspective, it is a set of interrelated tasks that transform input, raw materials, into output, products. In many organizations, it is the manufacturing process that consumes most of resources, but also delivers most of the value to the organization. This is the product, be it physical or service-based. All processes have the potential for creating impacts with negative consequences. For example, a collateral damage of production is usually pollution, and it implies costs like costs of compliance, of acquisition of control equipment, and fines. By understanding the process better, it is possible to reduce or eliminate these impacts, and such improvements often deliver reductions in energy and other resource use, or provide better productivity for the same level of resources. To improve the environmental behavior of the processes, there is a need to analyze what's currently happening. And for that, there are several techniques that focus on different factors and yield different results. I'm going to talk about two methods, material and energy analysis. Material flow analysis is a systematic assessment of the flows and stocks of materials within a system defined in space and time. Built on the first law of thermodynamics, the law of mass conservation, it contemplates a system and its processes as a living organism, allowing a researcher to investigate its metabolism. This is a simple material balance of input, stock, and output of a system and its processes. Essentially, it is an input-output simulation of a selected substance within a given system. Material flow analysis is an appropriate tool to investigate the flows and stocks of any material given system. It gives insight into the behavior of the system, and when combined with other disciplines such as energy flow analysis, economic analysis, and consumer-oriented analysis, it facilitates the control of an anthropogenic system. The objectives of the methods are: delineate the system of material flows and stocks by well-defined uniform terms, assess the relevant flows and stocks in quantitative terms, thereby applying the balance principle and revealing sensitivities and uncertainties, and present results on flows and stocks of the system in a reproducible, understandable, and transparent way, and use them as the basis for managing resources, the environment, and waste. This method is very useful for decision-making in resource, waste, or environmental management, providing policymakers with insight that can positively affect and improve inefficient guidelines. A company design and carry out a plan to reduce the quantity of waste and to improve its production processes by adopting advanced technologies. Material flow analysis was applied as a technique to analyze and manage both the economic and environmental impact of the investments. This company takes natural gas as primary input material. Carbon and hydrogen are the main elements and are applied in various products, byproducts, and waste. The overall system is shown here. It pictures the material flows across different processes, indicating relations in the industrial chain, as well as longitudinal material flows that demonstrate sequences in the industrial chains. In a system, each production process connects organically with the other processes and exchanges many kinds of material flows. The current situation is marked in blue, while the green section represents the long-term goals. Implementing these changes, the company managed to enhance its material utilization ratio, thus transforming more raw material into products and increasing its economic efficiency. Simultaneously, emissions are reduced, resulting in a better environmental and social efficiency. Material flow analysis can be also applied at an urban level, for example, to prospect strategic metals in urban mines, such as the following example when it was used to pinpoint neodymium within electrical and electronic equipment. Energy analysis examines the energy requirement in the whole production chain of a product. Not only concerns the direct energy use in manufacturing a product, but also the indirect energy requirements of a production process. These indirect energy requirements involve, for example, the energy requirement of production and transport of the material input or the energy requirements of capital goods. Therefore, energy analysis may be shortly defined as the process of determining the embodied energy of a product or service. This is the energy required directly and indirectly to produce it. A block diagram is a simplified representation of the relationship between the input and the output of a physical system. As input is considered a product to be transformed, and as output the useful product and the waste associated. System components or system blocks are referred as unit operations. Unitary operation A can receive various mass flows, M1 and M2 in this scheme, and consume a flow energy, EA, but produces only one useful output, M3, and a residue stream, MR. The energy consumed in operation A per unit of output flow is the specific consumption of a unit operation. A process may have several unit operations associated, and they may be linked in several ways. The analysis of the system by block diagrams has the objective of calculating the specific consumption of a product in the complex transformation processes. In the next video, we will continue with level 1 and go into more detail. Thank you for your attention.